Hello everyone. Today we are going to control a servo motor with a potentiometer. So that means using a potentiometer, the servo motor will actually change its angle. Ever seen a system that controls a motor using a simple dial or a joystick? One example is the movement of the arms of an excavator. So you can see the photograph below. How are the arms of the excavator moved? They are moved using a joystick kind of thing. A joystick is nothing but a combination of switches and potentiometers. Secondly, controlling an aircraft. You have seen the pictures of cockpits where the pilots, they change the speeds of the aircraft, they change the altitude of the aircraft by pressing buttons or moving some levers. Those levers are nothing but potentiometers. Okay. Today we are going to learn this now. The logic of the program looks like this. Number one, take input from a potentiometer. Number two, map the values which are the original values which are taken from the potentiometer to the values which are going to be used for by the servo. So that mapping, I'll tell you how the mapping is going to be done. Thirdly, you write the angle to the servo. So whatever is the angle, if the angle is 90, it actually moves the servo to 90 degrees. If the value of the angle is 180, it moves the servo to 180 degrees. So that is the movement of the servo that is going to happen. The basic sketch commands that you can see are, first of all, for the potentiometer, how are we going to set? We are going to set pin A0 to be set up for input. Now, A0 is an analog pin, and the potentiometer is actually giving you an analog input. So how do we set it up? We set it up with pin mode A0 comma input. So this means A0 has been set up as in the input mode, and you can see the analog pin has been used here. The value stored in a variable. So how is the value stored into a variable? So we say int var. Var is the variable that has been created, and we give the command analog read A0. So A0, whatever is connected to A0, the value is read from there and it is stored into variable var. Now you know that the values which are read by analog pins have values from 0 to 1023, but the servo basically uses values from 0 to 180. So how are we going to map them? We'll need to create a new variable. Int new var is equal to, now we give the map command. So we say map var as which has original values from 0 to 1023, and it is going to be mapped as 0 to 180. For the servo, the basic commands are, number one, we need to include the library. So we say hash include servo.h. Keep a note that servo has a capital S. Now create an object myServo of class servo. So myServo is the object that has been created and the class name is servo. Make sure the servo has a capital S and myServo has all small letters. This is something which we are creating ourselves. And we connected to pin number 10. How do we connect it to pin number 10? The object created was myServo. You could have created as ABCD, whatever you want to name it as. So whatever you have created, the same thing you say dot attach 10. So I've created myServo, so I'll say myServo dot attach 10. So this means it is basically now going to connect your servo through the software to pin number 10. How do you change the angle of the server? We say myServo.write var. So whatever is the value of var, that is going to be the angle of your servo. So if var is 45, this myServo is going to actually change the angle of the servo to 45 degrees. Let us now start by showing you a simulation first. So let us do that. This is the actual system. And the system basically comprises of three basic components. We have a servo motor here, we have an Arduino, and we have a potentiometer here. So the Arduino is basically taking input from the potentiometer and it is giving output to the servo. So whatever value is taken from the potentiometer is going to be written onto the servo. That means servo will move at that particular angle. Let us see the connections first. Let us see the connections of a potentiometer. Let's start with the input first. The potentiometer is always connected on one side the to the negative and on the other side to the positive. So that is always done. Please make sure of that. The Viper is connected. The Viper is actually giving input from to the Arduino. All right. So when the Viper is actually connected to A0. So this part of the connection is done. You can see that the Arduino, the 5 volts and ground of the Arduino is connected to this rail and further on to that rail. On the other side of that is the output part, the servo has basically 3 pins. One is the ground pin, which is actually connected to the ground rail. The power, which is actually connected to the positive rail, and the signal, which is actually connected to pin number 10. So whatever is given to pin number 10 actually goes to the servo. Make sure that whichever pin it is connected to, a PWM pin, because it is actually not switching a servo motor on or off. It is actually changing the angle at 10 degrees, 20 degrees, 30 degrees, whatever it is. So it's not actually a 0 or a 1. It is not actually a low or a high. It is actually multiple values. All right. So one thing to ensure is the input coming from the Viper is should go to an analog pin, and the output which is actually going from the Arduino to the servo should be from a PWM pin. Let us see the working of this. Let me start the simulation. You have seen that the potentiometer at the moment is at 0. So the angle of servo is at 0. Let me change the angles. If I change the angle, you will see that the angle of the potentiometer also changes. If I change it more, the angle will keep on changing. So if I have come to almost the middle of the potentiometer, you will find that the servo has come up to the middle. Not exactly the middle. The servo does not have accurate movement. Okay, it does not have accurate movement. If you actually need accurate movement, you should be using a stepper motor. Okay, not a servo. Servo is basically just used to make some movements. Okay, movement of an arm of a robot, maybe movement of the fingers of a robot, and so on and so forth. So these are basically done using servos. So if I change the potentiometer more, the angle again changes, and if I take it to the maximum, it is at 180 degrees. You can see actually the servo has not actually gone to 180 degrees. But anyway, it doesn't matter to us. So what we are actually basically doing is using a potentiometer, we are actually changing the angle of our servo. Let me show you the program now. The program starts with hash include servo.h. You know that it is basically to uh, include the library of the servo. Int pot in is equal to 0 a0. So potentiometer input from the potentiometer is actually going to a0, and servo out is the pin which is basically pin number 10. We need to create an object of servo type, so we say servo my servo. No problem there. In the setup function, we need to tell the computer that port in, which is pin number A0, is going to take input. So we specify that first. Then we need to tell the computer that my servo, whatever object I have created here, is actually attached to pin number 10. I could have said servo out, so let me put servo out there. No problem. That is why we used it. Serial.begin, you know what is being used for. Alright, int val is equal to analog read pot in. So we pot in is basically pin number A0. So it actually analog read reads pin number A0 and stores the value into val. And you know that analog input is basically has a range of 0 to 1023. Now, val can have the values from 0 to 1023, but the servo can go only from 0 to 180. So, how do we map it? This is the command to map it. Mapping means it changes the value of val, which is in the range of 0 to 1023, to 0 to 180. So, corresponding values from there, and it will store the values into a variable called new val. And how do we change the servo? We change the servo by giving the command my servo.write new val. So whatever is the value of new val, that value will be written into the servo. So servo will actually move in uh, that angle. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel. Don't forget to tap the bell icon so you never miss an update. I'd love to hear your thoughts. Feel free to leave a comment below and let me know what you think or what you'd like to see next. Your support truly means a lot. See you in the next video. Thank you.